longer than others? Okay, one of the things I got to do, and I was telling Mr. Lund, I added this up, I graded 1,620 homework questions. Some of them were easy because there wasn't anything written down. Yes. But I'm glad to help you. But I still had to look at them. One of the things we're going to do today, we're going to kind of pair up. I'm going to go over the physics homework, or the friction homework that you guys had, that some of you did over the break. But before that, in grading the vector addition worksheets, one of the things I try to do, like if I'm grading a test, if you get the answer wrong, obviously I mark it wrong. If multiple people get the same wrong answer, I try to figure out what did you do to get the wrong answer so that I can either clarify with you or realize multiple people are making the same mistake. So one of the things I want to do is go over a little bit my really fast vector addition review, because I'm seeing a lot of the same mistakes when doing the vector addition. So I'm going to use one of the examples from the worksheet was the two girls playing soccer. So Jenny and Sue kick the soccer ball. Sue kicks it 66 newtons north, a force of 66 newtons going north. Jenny kicks it, a force of 88 newtons going east. This is on one of the worksheets. Here's my lovely little clip art because it's cool. So the one girl's kicking it towards the north, the other girl's kicking it towards the east. A lot of you guys drew something like this without the quality soccer ball. But
the quality soccer ball.
This is fine for visualizing. You're looking at one object experiencing two forces, one going north and one going east. That's fine as far as visualizing the situation, but that's not how you add the vectors. And I'm pretty sure you guys have had a section on this before, but one of the interesting things is some people were doing it right on some of the questions and doing the exact same kind of question wrong the other times. And you'll notice it doesn't matter which way you draw it, you're still going to get the same result, because if this is a 90-degree triangle, what do we use to get the result?
Yeah.
Right. All you have to do is a squared plus b squared square root equals r. What will mess you up on is the angle. And what do all of these questions say? What is the magnitude and direction of the resultant force? So we're asking you for the direction too. So if you draw the picture wrong and make your angle like this, you're going to get the wrong angle. But like we said, the resultant is just Pythagorean theorem. So for this one, it was r squared equals square root of this, 110 newtons. And the way I have the angle drawn, if you look in terms of a compass, most of these, they're giving you a geographical direction. One force goes north, one force goes east. Here's a nice little shortcut. What is north plus east?
Northeast.
Right. So a northern force added to an eastern force is northeast. If you don't get an angle that's northeast, then you have the angle wrong. So you always want to have your vectors drawn, what they call head to tail, where the arrow is the head. The head of the first one is added to the tail of the second one, and then you get your resultant, and the angle is the one in between. So if you look at your homework, if you got the resultant magnitude, but not the direction, I probably marked it wrong. If you had the right degrees, but kind of drawn in the wrong direction, I probably gave that to you, but we probably won't on the test. You want to pay attention to the compass. North is 0 on a compass, 90 is east, 180 is south. So pay attention to the northeast, southwest, southwest, or southeast, that sort of combination for when you're putting the directions on there. As far as the friction assignment goes, this was the homework. It was number 17 through 25 on pages 128 to 130. A real quick, my real fast friction starter kit. One of the things I said on Tuesday is anytime we have a new topic, you guys get a new equation, yay, and you get homework. For the friction problems on this section, it will get more complicated in the future, but for this section, this is really all you need to know. This is the definition of the coefficient. It's the ratio of the friction force to the normal force. And here's a nice free body diagram. If you draw something that looks like this for almost all of these problems, it's a lot easier to follow. What is the force due to gravity? What do we call that? No, that's the acceleration. What's the force due to gravity?
FG.
It's the weight.
I don't know what that was.
A lot of, I mean, in America, we usually use weight and mass to kind of refer to the same things. Technically, they're not. Your mass does not change no matter where you go in the universe. Your weight is a function of your mass and the gravity force that that mass feels. That's why we were talking about the examples. If you go to the moon, you weigh less. Your mass is the same, but the gravity is less, therefore you weigh less. So one of the ways to start doing this is, see, nice little back and forth. If you do the downward force as mg, that's the weight, the mass of the object times the acceleration due to gravity. And for all the ones we do on these homework assignment, on a flat surface, this is where it gets easy. On a flat surface, like the textbook on the table, the normal force is the same as the gravity force, which is the same as the weight, which is the same as mg. So that makes it really easy. If we tell you the weight of the object, that's the normal force in the opposite direction. And the other thing is that a net force, when we're talking about acceleration, a net force is the applied force minus the friction. So a lot of times what you see in the homework problems is we give you the weight, and we give you the acceleration, and ask you for mu, the coefficient. Or we give you the coefficient in one of the forces and ask you for the other. So all you have to do is manipulate this equation. But here's the important part to remember. Like I said, on a flat surface, the normal force and the weight are the same magnitude, opposite direction. So you don't even have to calculate it. Yeah?
Where's the static friction?
What?
Where is the static friction?
All that means, the distinction between static and kinetic is whether or not it's moving. So I was using, where's my book? I'll just use this. If you have an object on a surface that's not moving, static friction is what stops it from moving until I push with enough force. And then once it starts moving, kinetic friction takes over.
Okay.
The concept is the same, it's just whether or not it's moving. So to try to go through the homework kind of quick like we were doing before, number one, who can tell me why is it relevant that the object is moving at constant speed? Anyone? What? Right. Constant speed means acceleration is 0. And if acceleration is 0, what's the net force?
0.
Right. And in cases where the acceleration is 0, the applied force and friction are the same. So in this one, we've given you both the weight of the object and the applied force, which turns into the frictional force. So the coefficient is just 36 divided by 52, which is 0.69. So you should have gotten 0.69. Trying to do this without showing you guys the answers. Next one, exact same problem. Only thing is, now we've given you the mass instead of the weight. So like I said, if on a flat surface, normal force is the opposite of the weight. You have the mass, how do you get the weight? Thank you. mg. And we gave you the force to get it started moving. So in this one you should get 0.099. It's just the force. Let me write that down.
The little u
Here's your starting equation.
stands for the coefficient. Static friction, which is a given number.
Right, that's the starting equation, and then you can manipulate it. In this case, we're asking for the coefficient of friction. Again, we gave you the force of the object. Did anybody get that? 0.099?
No.
No. Did? Okay.
Well, I don't know how though.
Mr. Cowboy, does the U stand for static?
No, the S stands for static. U is just the coefficient. It's the symbol they use for the coefficient of friction.
Okay.
And then these things will have an S or a K subscript.
Okay, so
Like the S means static. The concept, I mean, the way you calculate it is always the same. It's just the concept of whether or not it's moving.
Okay.
And on the static one, what you're looking for is there is no kinetic friction until it starts moving, and then it goes from static to kinetic. So you can't have both at the same time. But the static one tells you how much force does it take to get it to start moving. this one, kind of the same thing. I'm going to actually show because I'm getting myself confused. Mr. Ames is dragging a box of books from his car across the pavement. It's a 134 Newton box of books. The coefficient of friction between the pavement and the books is 0.55. How hard does he have to push to get it to start?